Okay, so today we're going to go over some integration by parts questions. All these questions were featured in IB maths exams, HL maths that is. And the first one we'll be doing is the integral of arc sine x dx. Now what you might notice is that this seems perhaps a bit strange because you know how to differentiate arc sine x because it's given in the formula booklet, but you don't really know where to start for integrating it. So you're going to want to look at your formula booklet and you go to the derivative of arc sine x equals 1 over the root of 1 minus x squared. So how you're going to do it is you're going to say that this is the same thing as the integral of 1 multiplied by arc sine x dx, obviously. And then what you're going to do is you're going to let u equal arc sine x, and therefore du by dx equals 1 over root 1 minus x squared, as we saw in the formula booklet. And then you're going to say dv by dx equals 1, and therefore v equals x, because we're just integrating 1 with respect to x. So we can rewrite this out using the traditional integration by parts method. We're going to do, this is all equal to x multiplied by arc sine x minus the integral of x over root 1 minus x squared dx, right? Because this is just the v times u minus the integral of du by dx multiplied by v dx, right? Now we have this here, which looks a bit more manageable, and after a bit of looking, you should be able to see that you can make quite a nice substitution here. So, because if we let u equals 1 minus x squared, our derivative of that is going to be an x to the 1 term, right? And then when we substitute when we manage to get du in by substituting it out for dx, the x terms should cancel. So the x on the numerator here and x on the derivative of this denominator term here. So we're going to say u equals 1 minus x squared, du by dx equals minus 2x, and therefore 1 over minus 2x du equals dx. So this whole thing equals x multiplied by arc sine x minus the integral of x over root u multiplied by 1 over minus 2x du, which equals x arc sine x plus 1/2, because we can take out the half term, 1 over root u du. Now if we take this bit, this is the same as u to the minus 1/2, and therefore we have the integral of u to the minus 1/2 du, which is equal to, well, if we just do normal integration rules, 2u to the power of 1/2 plus c, right? So therefore, our final thing is x multiplied by arc sine x plus 1/2 times this, so 2, this is root u, isn't it? Yes. Plus c. And if we substitute back in u for that, then we get x multiplied by arc sine x plus 1/2 times 2 is just 1. So root of 1 minus x squared plus c. Okay, so next we are going to find the exact value of the integral from 1 to e of x squared multiplied by ln x dx. So first we're just going to do it as an indefinite integral and then we'll apply the limits after. We don't really, well, we do in theory, but it's a lot simpler to differentiate ln x than it is to integrate it. So we're going to say u equals ln x du by dx equals 1 over x. dv by dx therefore is equal to x squared, and v, just by normal integration, is equal to 1/3 x cubed. So this whole thing is equal to 1/3 x cubed multiplied by ln x minus the integral of 1 over x multiplied by 1/3 x cubed dx. We can simplify that integrand and factor out the 1/3 to give us minus 1/3 integral of x squared dx. Then we can just do this again. We already did that for the early bit. So 1/3 x cubed ln x minus 1 over 3 multiplied by 1 over 3 x cubed plus c, which is equal to 1/3 x cubed ln x minus 1 over 9 x to the 3. Now, let's just evaluate that straight away from 1 to e, right? And we're just going to do this through the normal fashion. So 1/3 e cubed ln e minus 1/9 e cubed, and then minus all of this. So 1/3 1 cubed ln 1 minus 1/9 1 cubed. So we have e 3 over 3, and ln e is just 1, so we leave that as that, minus e cubed over 9, and then ln 1 is 0, as e to the power of 0 equals 1, and therefore we just have minus 1/9 there, minus 1/9 plus 1/9, and that's our answer. We can simplify it slightly more just through some pretty basic algebra. We can just see that that's equal to 2e cubed plus 1 over 9, and that's our final answer. Okay, finally, one more question we're going to do is the integral of x multiplied by sec square x dx. Now, what you'll see in the formula booklet, sec square x should immediately look quite familiar, and that's because the derivative of tan x is sec square x. Therefore, we can integrate sec square x really easily into just tan x plus c. So therefore, we are going to let dv by dx equal sec square x, and that follows that v equals tan x, and then u equals x, du by dx equals 1. Right, so then just by the normal way, x tan x minus the integral of tan x times 1 dx. So now we just have to try to find the integral of tan x. You'll notice in your formula booklet you have the integral of sin x and the integral of cos x, but no integral of tan x. So we have to figure this out ourselves. So let's just do that separately. The integral of tan x dx. This is equal to sin x over cos x dx. And then what we'll find is we know that the derivative of sin x is cos x, and we know that the derivative of cos x is minus sin x. So we can do a little u substitution here. So u, and this is obviously a different u, but we'll use it for the sake of simplicity. U equals cos x, therefore du by dx equals minus sin x, therefore 1 over minus sin x du equals dx. So we can substitute that in. What we're going to get is minus, and the signs will cancel, sin x's will cancel, and the minus from here. So 1 over cos x, which is u, du, which is obviously equal to minus the natural log of u, plus c, which is equal to minus ln cos x plus c. So if we put this back into the original thing we were trying to find, we have x tan x, and then minus, so plus ln of cos x plus c.